Number 10 on page 588. Remember, focus on this right angle because that's where all the geometric means come from. Z is a geometric mean, 6 is a geometric mean, and Y is a geometric mean. That means Z will be in a proportion and show up twice on a diagonal, and 6 will be in a proportion showing up twice in a diagonal, and Y will be in a proportion showing up twice in a diagonal, because from that right angle, like the spokes in a wheel, all three of those parts are geometric means in their own right, which means they're in the perfect middle. They're in the perfect multiplicative middle of two other values. So, what is each of these parts the middle of? They're in the middle of nothing to do with each other. They're in the middle of everything out here on the hypotenuse of the original right triangle. So your options to fill in all of these blanks, your options are 12 or x or the entire hypotenuse, which is in this case 12 plus x. Those are your options. All right, so for each one of the geometric means, let's start with the yellow one. It's the middle of two things, and it's either the middle of x and 12 or x and the red, x plus 12, or 12 and 12 plus x. And which is it going to be? And we derive this with our similarity statements on that day in class. The yellow geometric mean is the middle of the part x, which is touching, and it's not touching 12, but it is touching the whole hypotenuse, 12 plus x. So y is the geometric mean of x and 12 plus x. Okay, what about this geometric mean? It's the geometric mean of the part x, which is touching, and the part 12. So the altitude, which is in the middle of the two parts of the hypotenuse, x and 12. And then finally, the blue geometric mean is the geometric mean of the part 12, which it's touching, and it's also touching the whole hypotenuse, 12 plus x. So z is the geometric mean of 12, and the entire hypotenuse, 12 plus x. When you do problems like this, always set up a proportion for this geometric mean and this one and this one. Set them all up first. Once you have them all set up, then ask yourself, which one should we solve? Not this one, because it has x's and y's. This one only has x's, so that's the one we can solve. If you had started here, you're not going to be able to find z or x because there's two variables in one equation. Two variables in one equation. So we start with this one. All right. Let's cross multiply. 6 times 6 is 36. 12 times x is 12x. Dividing both sides by 12. We now know what x is. X is equal to 3. And now that we know that, we can substitute it in, for example, there. And now we have z over 12 equals 12 plus 3, which is 15 over z. All right, when we cross multiply, we'll have z times z, which is z squared, and 15 times 12 is 180. So taking the square root of both sides, z is the square root of 180. All right, let's come on over here and find y. Remember, x is 3. So 12 plus 3 is 15. And when we cross multiply there, y times y is y squared, and 15 times 3 is 45. Taking the square root of both sides, y is the square root of 45. All right, this problem is done, but let's practice writing these radical expressions in what we call simple radical form. Let's start with the square root of 45. 45 is the same as 15 times 3, but we can't take the square root of 15 or 3. Neither is a perfect square. How about 9 times 5? The square root of 45 is the same as the square root of 9 times 5, which is 45. And this is a perfect square, so we can take the square root of 9 and get 3. And there y is in simple radical form. So this was our answer. This is our answer in simple radical form. When the radicand is relatively small, like 45, we can pretty quickly look at the different ways of multiplying two numbers to get 45 and pick the one with the perfect square. But when the number is large, like 180, you might see that this is 5 times 36, where 36 is a perfect square, but you might not. So you might try the factor tree method. Changing 180 to simple radical form, we can say we know that 180 is 2 times 90, and 90 is 2 times 45, and 45 is 9 times 5. So the square root of 180 is the square root of 2 times the square root of 2 times the square root of 9 times the square root of 5. Another way of thinking about the factor tree is like this. 180 is the same thing as all of its prime factors. 2 times 2 times 5 times 3 times 3. So the square root of 180 is the same thing as the square root of 2 times 2 times 5 times 3 times 3. 2 times 2 times 5 times 3 times 3. So when you have a factor squared, that makes it a perfect square, like in this case 4, or in this case 9. And we can take the square root of perfect squares, because square roots and squares cancel each other out. So the square root of 4 is just 2, and the square root of 9 is just 3, and 5 stays under. So we've got 6 root 5. So z in simple radical form would be 6 root 5. So x is 3, z is 6 root 5, and y is 3 root 5.